Climate and Weather by Carol Levine. What is Earth's atmosphere? Gases in air. An atmosphere is a blanket of air that surrounds a planet. Earth's atmosphere is mostly made up of nitrogen and oxygen. The rest of the atmosphere is made up of tiny amounts of about 10 other gases. Gravity keeps Earth's atmosphere in place. Many of the gases in Earth's atmosphere come from the molten rock within Earth. Nitrogen, water vapor, and carbon dioxide were released as molten rock cooled down. For more than 4 billion years, many gases have escaped Earth during volcanic eruptions. At one time, the atmosphere had little oxygen in it. Plants on Earth take in carbon dioxide and release oxygen during photosynthesis. Over millions of years, this has put oxygen into the atmosphere. Today, the amount of any gas in the atmosphere is mostly the same everywhere on Earth. The amount of water vapor, however, can change. Some areas have almost zero water vapor in the air. Other areas, such as tropical regions, have air that is as much as 4% water vapor. The polar regions have less water vapor in the air than the tropical regions do. Air pressure and temperature. The gases in air are made up of moving particles. These particles are always moving and bumping into other matter. Air pressure is the measure of force per unit area with which air particles push on matter. For instance, air particles you blow into a balloon push on its sides, so air pressure is what makes a balloon get bigger. Air in the atmosphere pushes on matter too. Air pushes on all sides of objects. Air is pushing on your body right now. Air in your body pushes out with the same force that air outside pushes in. So you do not feel air pushing on your body because it is pushing equally from all sides. The force of air pressure is related to air temperature. Particles are tightly packed together in cool air. They are farther apart in warm air. This means cooler air has greater air pressure. Air pressure is also related to how much water vapor is in the air. Dry air has more pressure than moist air. The higher you are above Earth's surface, the lower the air pressure is. The pressure is greatest near the surface because more particles are pushing down from above. A barometer is an instrument used to measure air pressure and altitude. In the photo below, the metal can has had the air pumped out of it. This caused the air pressure inside the can to be lower than the pressure outside the can. The higher air pressure outside pushed in, crushing the can. You may have felt changes in air pressure while driving up or down a mountain, flying in a plane, or riding a fast elevator in a very tall building. As your altitude changed, changing air pressure may have caused your ears to pop. As you go up, the pressure around you gets lower. As you go down, it gets higher. The popping in your ears happens when the pressure inside your ears changes to match the pressure outside. Airplanes fly at high altitudes, where the air pressure is about half of what it is at Earth's surface. Airplane cabins are pressurized to keep passengers comfortable at these very low pressures. Layers of the atmosphere. The atmosphere is made up of layers. The layers have different characteristics. The thermosphere is the highest layer. The air particles there are far apart. Sometimes electrical energy from the sun disturbs gas particles in this layer. This causes auroras or glows to happen. The mesosphere is the coldest layer. The higher you go in this layer, the colder it is. The stratosphere contains most of the ozone in the atmosphere. Ozone is a gas that takes in the sun's harmful ultraviolet rays. As you increase in altitude in this layer, temperature also increases. The troposphere is the lowest layer. People live in this layer. More than 75% of the air in the atmosphere is in the troposphere. Weather happens here. It is warmest near the surface. As you go higher in the layer, it gets colder, and air pressure decreases. A. Thermosphere. Sometimes particles of gas in the thermosphere are disturbed by electrical energy from the sun. When this happens, glows or auroras occur that can be seen in the night sky at high latitudes. B. Mesosphere. The mesosphere is the coldest layer. Temperatures get cooler as you move higher in this layer. C. Stratosphere. Temperature increases with altitude in the stratosphere. This layer contains most of the atmosphere's ozone. D. Troposphere. The troposphere is the layer in which you live. More than 75% of all the air in the atmosphere is in this layer. All weather takes place here. Global winds. Wind is moving air caused by differences in air pressure. Winds generally move from areas of high pressure to areas of low pressure. When air rushes out of a balloon, it is moving from an area of higher pressure to an area of lower pressure. Changes in air temperature change air pressure. Heated air is lighter. As its particles move faster, they move farther apart. Warmer air rises, while colder, heavier air sinks. Heat being transferred by moving air is called convection. Winds move across Earth as warm air rises from the tropics and cold air falls from the poles. Warm air that rises at the equator cools as it moves up and away from the equator. At about 30 degrees north and south of the equator, the air sinks back to Earth, causing large wind currents known as trade winds. Local winds. Rising and sinking air also creates local winds. The temperature of large bodies of water does not change as quickly as land temperature. Sunlight raises the temperature of land. The air over the land gets hotter and rises, but the air over the water stays cool. The cool air from above the water flows in underneath the rising warm air above the land. At night, the land becomes cooler than the water, and the flow of air reverses. The air temperature of land near water stays more even because of this pattern. Winds and local weather. Water vapor in the air condenses when air rises and cools near the equator. This causes a lot of rain in this region. At 30 degrees north or south latitude, dry air falls toward Earth. This is where some of Earth's deserts are located. Local weather is also affected by jet streams. A jet stream is a band of wind moving at high speed in the upper troposphere and lower stratosphere. It moves from west to east. The jet stream affects local weather by moving air of different temperatures from place to place. How do clouds and precipitation form? Humidity. Humidity is the amount of water vapor in the air. Water enters the atmosphere as water vapor within the water cycle. Air temperature determines how much water vapor the air can hold. Warm air can hold more water vapor than cool air. Dew, fog, or clouds form as air gets cooler and water vapor condenses or changes from a gas to a liquid. No matter what the air temperature is, there is a limit to the amount of water that air can hold. Relative humidity is the amount of water the air contains compared to the amount of water the air could hold at its current temperature. 100% is the highest relative humidity. It means that the air is holding as much water as it can. Cirrus clouds are thin and look feathery because they form high in the atmosphere where temperatures are below 0 degrees Celsius. Fluffy cirrocumulus clouds form high in the atmosphere. These clouds are made of ice crystals and do not usually result in precipitation. Dark, heavy cumulonimbus clouds can reach high into the atmosphere. They usually result in a short, heavy rainfall or a thunderstorm. Cumulus clouds usually form near Earth's surface. They usually form late in the day when air warmed by land is rising into the atmosphere. Stratus clouds form between 2 and 6 kilometers above Earth's surface. They are flat, white clouds that will produce mist or a steady drizzle. Clouds. Clouds form when air rises and cools. Cooler air can hold less water vapor. This causes condensation of the water in air as it rises. Tiny droplets form around dust, smoke, and salt particles in air. Millions of these droplets collect and form clouds. If the temperature in the cloud is cold enough, the water droplets freeze to form ice crystals. Clouds get larger as more droplets form. Clouds are grouped by their shape and by how high they are above Earth's surface. There are 3 main cloud forms. Cirrus clouds are thin and made of ice crystals. They do not result in precipitation. Cumulus clouds are puffy. They form when air warmed by land rises. Stratus clouds are flat white clouds that may produce mist or steady drizzle. How precipitation forms. Precipitation is all the forms of moisture that fall from the atmosphere to the Earth's surface. Rain, sleet, snow, and hail are common forms of precipitation. Clouds produce precipitation when they hold a lot of moisture. Water droplets and ice crystals in clouds get larger when water clings to them. When the crystals are large enough to fall, they fall as precipitation. Rain and snow. Rain falls when water droplets or ice crystals fall from clouds through temperatures that are above 0 degrees Celsius or freezing. Snow falls if ice crystals drop from clouds and the temperature under the clouds is below freezing. Snow crystals can be feathery and 6-sided snowflakes or flat hexagons. The shape of snowflakes depends on the temperature and the amount of moisture in a cloud. Sleet and hail. Sleet forms when rain falls through a large layer of freezing air. The rain freezes as it falls. It reaches the ground as raindrop-sized particles of ice. Freezing rain, called glaze, happens when air is cold but not cold enough to freeze the water. The drops freeze when they hit a freezing surface. Hail is round, hard particles of ice. Hail usually falls in warmer summer months. When winds toss ice crystals up and down inside cumulonimbus clouds, hail forms. Droplets of water attach and freeze to the crystals as they move and freeze. This happens over and over until the hailstone grows heavy enough to fall. Hailstones can be as big as baseballs. What causes weather and climate? Air masses and fronts. Weather is the condition of the atmosphere at a particular time and place. Air masses and fronts produce the weather. An air mass is a very large body of air. The whole mass has about the same temperature and humidity. The area over which it forms determines the temperature and moisture of the air mass. Air masses of different temperatures do not mix easily. A boundary, called a front, forms between them. Weather at a front is usually cloudy or stormy. Meteorologists are scientists who study weather. They track air masses to predict weather conditions. Cold front. A mass of cold air runs into a mass of warm air, forcing the warm air above the cold air. As the warm air rises, it cools and condenses. Clouds form, and heavy rain or snow may follow. Cold fronts move more quickly than warm fronts. Stationary front. A warm air mass and a cold air mass meet, but neither one moves toward the other. As its name implies, a stationary front does not move quickly. It can stay over an area for several days. The weather produced is similar to a warm front. Warm front. A mass of warm air runs into a mass of cooler air. The warm air is forced above the cooler air. As the warm air rises, it cools and condenses, forming clouds. Periods of steady rain or drizzle result. Severe weather. What should you do when you hear thunder? Thunder can't hurt you, but the lightning that goes with it can. Knowing what to do can help keep you safe during severe weather. Thunderstorms. A thunderstorm is a small, powerful storm that produces strong winds, heavy rain, lightning, and thunder. They happen all the time. At any given time, about 1,800 thunderstorms are occurring around the world. They happen more in spring and summer, but they can happen in every season. Every thunderstorm has lightning and heavy rains. This can be dangerous. Lightning can kill people. Heavy rains can cause flash floods. Tornadoes. A tornado is a violent funnel-shaped air column that extends from a thunderstorm to the ground. It has very strong winds that can reach speeds of 419 kilometers an hour. They form from thunderstorms and come about quickly. This makes them hard to predict. The path of a tornado can change quickly, so it is also hard to predict its path. Tornadoes can happen all over the United States. They are very common in the Plains area between the Rocky Mountains and the Appalachians. Severe weather safety. Thunderstorms. Find shelter in a building or car. Keep car windows closed. In the woods, take shelter under the shorter trees. If boating or swimming, go to land and find shelter. Outside in an open space, squat low to the ground. Place your hands on your knees with your head between them. Make yourself as small as possible. Tornadoes. Take shelter underground in a basement or storm shelter. If no basement or shelter, go to an inside room, hallway, or closet on the first floor, away from windows. Outside, lie flat in a ditch. Lie face down and cover your head with your hands. Hurricanes. A hurricane is a large, spiraling storm that forms over warm ocean waters. It starts as a tropical storm over the southern Atlantic Ocean, Caribbean Sea, Gulf of Mexico, or eastern Pacific Ocean. The winds blow at least 119 kilometers an hour. These winds cause lots of damage when the storms move over land. Hurricanes begin as thunderstorms in areas of low pressure. Winds blow in and spiral because of the turning of Earth. Evaporation of ocean water adds moisture to the air. The water condenses as the warm air rises. This process releases a lot of energy. Large amounts of warm, moist air keep a hurricane moving. The storm loses energy and dies as it moves over colder water and drier land. Severe weather safety. Hurricanes. Prepare a disaster plan and a disaster supply kit ahead of time. Evacuate if told to do so. If you don't need to evacuate, stay indoors. Avoid using the phone except for emergencies. Predicting weather. Weather can change quickly. People use forecasts to prepare for weather. There are weather forecasts on radio and television, in newspapers, and on the Internet. These sources also give instructions and information about severe weather. Weather forecasting begins with looking at weather all over the world. Meteorologists examine temperature, wind speed, humidity, and air pressure. They use computers to study the data. This helps them make weather predictions. In the United States, the National Weather Service gathers this information. Forecasters across the country use this information to predict both national and local weather. Gathering data. Meteorologists use tools to predict the weather. Weather is the result of many complicated processes, but many of the tools used to predict weather are very simple. Thermometers measure temperature. Barometers measure air pressure. Anemometers measure wind speed. Rain gauges measure the amount of precipitation. Meteorologists also measure factors above Earth. Weather balloons are released from weather stations all over the world. They gather information about the weather in the upper troposphere. Technology has helped weather forecasts become more accurate. Doppler radar uses radio waves to measure wind speed and precipitation and to tell what direction storms are moving. Weather satellites track weather data. One group of weather satellites is called GOES. Each GOES satellite stays fixed in orbit over the same part of Earth. Data from all of the satellites can be combined to see almost all of Earth. Climate. Weather and climate are different. Weather can change constantly. Climate is the pattern of weather that occurs in an area over a long period of time. This period is usually 30 years or longer. Climate is usually described as average temperature and average precipitation. Different areas of Earth have different climates. Sunlight, ocean currents, and gases in the air, among other things, affect climate. Large bodies of water affect climate because water warms and cools more slowly than land does. So climates close to the ocean are milder than those farther inland. Pollution can affect climate. Carbon dioxide, which results from the burning of fossil fuels, can contribute to increased temperatures worldwide. This is called global warming. People can control some factors that affect climate, such as the production of carbon dioxide. Factors that affect climate. Volcanic eruptions release large amounts of ash and smoke into the atmosphere. These materials can block sunlight, causing Earth to cool. The Gulf Stream current brings warmth from the equator toward the poles. Air warmed by this current helps keep the climates of England and Ireland mild in winter. Earth's polar regions receive less solar radiation, and ice reflects much of it. This keeps these areas cold. As air rises over mountains, it cools and water vapor condenses. The western slopes of mountains receive a lot of rainfall. The eastern slopes are generally dry. Climate and weather are vital to life on Earth. It is important to know as much about them as we can. We need ways of predicting weather so we can be prepared for severe weather. Science is advancing all the time, providing new technology to help meteorologists study and forecast the weather in our world. Water from oceans and other bodies of water evaporates and helps make the climate more humid. As moist air moves over land, it can cause precipitation. When forests burn, carbon dioxide is released into the atmosphere. And when forests burn or are cut, fewer trees remain to absorb carbon dioxide. Increasing levels of carbon dioxide in the atmosphere may be causing global warming. Low clouds reflect sunlight, which makes Earth cooler. However, high clouds help keep Earth warm by trapping heat in the atmosphere.